Everyone, I'm here with Dr. Joan Cotter, and we call her Joan. And she is a math teacher, an educator. She wrote this book, and I've been so excited to talk to her because I have been getting so into math, and I've been realizing that I wasn't really taught well. So it wasn't completely my fault, though I do take responsibility for maybe not, trying myself to learn math. But anyways, enough about me. Joan, welcome.
Thank you, Jerry.
And let's just get started with this book. What made you decide to write this book?
That's a good question. There's so many different things that I've changed that I think about, and I always thought it'd be nice if people could understand where I came from. And for people who are interested in research, and today more people are, there are 85 references in the back.
Wow, 85 references in the back.
85 references.
Oh, right here.
Yes.
So 85 of these.
Yes.
So in a way, if people wanted to dive in more after reading this, they can look at your sources.
And not only that, I tell you in the text itself which one you need to look at.
Oh, wow.
What you're interested in.
I see. And so one of the things we'll definitely talk about is there's a heavy use of the abacus in this. So, 算盘, as those of you know.
Yes. This is a special abacus, and it's used with the symbol on top. Notice the beads are in two colors, and that's a very important reason. We know that babies 5 months old can already add and subtract up to 3.
Oh, I didn't know.
And the purpose of an abacus is not to teach counting. You don't have to count. That's the whole purpose. So, babies, as I said, can add and subtract up to 3. And it's called subitizing. Subitizing. It's a special new word that came out in the 1940s, which means suddenly that you know how much that is. You don't have to count it. Ask a 4-year-old how old they are, and what do? They put up 4 fingers. They don't say, I'm 1, 2, 3, 4. They know they're 4. And they know when that birthday comes, they get to put up 1 more, which is very, very important. Now, when we go past 5, it's a little harder to see quantities. In fact, try and imagine 8 apples in your head without grouping them. I can't do it either. But think of 5 as green and 3 as red. Now, the apples coming in, most people then can see it. Now, this idea of grouping in 5s is not a new idea. Think of the Roman numeral 8. 5 and 3. Think of music. 5 lines. And if you play the piano, you have extra ledger lines. It sometimes gets hard. You don't even know what they are. As our brains are designed to match our hands, or our hands match our brain, whichever way you want to look at it. So when you get past 5, you have to group in 5s. And that's the reason the beads are grouped in 5s. So you can see right away that that's 7. If you want to hold that for a second.
Yeah, sure.
And you can see how much that is. That's 7. And I say we start from the left, but I'm across, so that's why I'm doing it with my right hand. If you want to get technical. So that's 7. And of course there's 9, and there's 10. And a lot of children already know a 5 anyhow. High 5s and 2 5s make 10. I had one little girl in my class. She said 9 was her favorite number. I think she felt sorry for it because it was so close to 10.
I see.
So then when you go past 10, I also use something called the math way of counting, which is used in Asia. So when you get past 1, then you say 10, 1.
Yes, that's how I learned it in Chinese. 11, not 11, not 11 in Spanish. No, 11, 10, 1.
There's 10, 2. And as he says, there's 10, 5, 10, 8, 2, 10.
Yeah, 20, yeah.
And 3, 10, and 4, 10, and 5, 10.
Yeah.
And so on. And again, we change the colors down here so you don't have to count. So you can tell right away how much this is. I'm going to put a number on here. And you won't have to count the beads, and you'll be able to tell me how much this is. Let's do this number. Can you see that that's 64?
Yeah.
You didn't have to count it.
You didn't have to count it and that's the beauty of how you switch the colors around. Because I know, okay, this is 510, and then, oh, look at that. Now we get another 610, and then 4.
Right.
Ah.
Save some. And the best part is you can see it in your head.
Yeah, yeah.
You get a mental picture of it.
Yeah.
If they were all the same color, you couldn't do that.
Yeah.
And a lot of people in this country think that an abacus is to teach counting. Where the truth of the matter is, abacuses were designed so you didn't have to count.
Yeah. Yeah.
Yes.
I still remember in the 90s, before computers were widespread in China, there were these abacus masters who sometimes would be in stores. You know, they knew how to do the abacus. And were they counting with the abacus? No, they were doing multiplication and division and all that with the abacus because they remembered the steps. If they had to count on top of doing the steps, they would never be able to do it as fast as a computer. So
That's right. Well, at one time, I knew how to do it on Japanese abacus. Sorry, I could do the Chinese, but, well, if you do the Japanese, you do Chinese.
Yeah, yeah.
But, yes, and I was more accurate than I was on a calculator.
Yeah, I believe that.
But I've lost it because I haven't been doing it lately.
Mm-hmm.
I don't have any need to. Now, let's try adding. Let's add 4, plus 3 more. There's 4, here's 3. Actual adding means pushing them together. And you got your answer instantly. No counting needed. There's one boy that has a mental abacus in his head and he tilts his head when he clears it.
That's pretty funny.
Yes. And multiplying, that's really cool. Here is 6 taken 4 times. You agree? Can you see the 6 taken 4 times? And how much is it? 10, 24.
Oh, wow.
So, and you can do, I did this with my 5-year-olds, and they said, don't give us easy ones like 2 times 4. Give us hard ones like 9 times 8. Because what they love to do is we call it take and give. You want to hold this for me?
Sure.
Jerry, we'll put on here, we'll put 91. I'm sorry, 81. Now, how much is that? Well, if I take one from here and give it here, this is called take and give. And I could take 2 from here and put them here. Whoa. I could take 3 from here, put them here. And they just thought this was so much fun. There's my answer.
Wow. Wow. You know, the reason I'm saying wow is because when parents were scratching their heads punching a wall 10 years ago, when a lot of the schools, public schools, were trying to do the Common Core, they were trying to teach this, but less effectively. What Dr. Cotter just did with that take and give was exactly what the Common Core was trying to do to teach multiplication and division, but not effectively. Like, I'm literally understanding what the Common Core was trying to do, but through this method.
Well, let me show you some neat things for adding.
Mm-hmm.
Let's add 7 and 8. Now, do you know what 7 and 8? See the 10 over here?
Mm-hmm.
So therefore, it's 10 and 5.
Yeah. Yeah.
5, 10, 5.
It's the color coding. It really makes a difference.
It does. And it also allows you to see it. What you can visualize, what you can subitize, you can visualize. So if you can't subitize it, you can't visualize it.
Yeah. I'm going to remember this word because I argued more than 10 years ago, actually 9 years ago, I told people that the Chinese language and any language that starts you counting in base 10 helps you in understanding what multiplication is, but I didn't have that word subitized. Now I have an extra word to make my argument because I don't think it's hard for a Chinese kid to understand that 10 plus 1 is 11, right? But like,
oh no, it's obvious.
Yeah.
What is 10 plus 1? 10, 1.
Yeah.
Duh.
Yeah. But if you say 11 to a kid, the kid's not going to initially understand that, I don't think.
Well, let me tell you how I get back to what we call the traditional way of counting, because we do have to teach that.
Mm-hmm.
So it's for us not to start off. Enter 410, and it has another name. It's also called 4T, and the TY means 10. So 4T, 410. That was pretty obvious. And the same thing is true for 60, 70, 80, and 90. 30 and 50, we can't say 3D and 5T. We have to switch it a little bit, 30 and 50. Then we're left with two of them, 210. And we used to count 1, 2. TWO is 2, and we used to pronounce the W. So we still do in 20, twin, twice, and 12. So that's where 20 comes from. It's 210 is 20. Then we have the teens. So let's say there's 10, 4. And then we play a little word game. If I say mailbox, you say box mail. If I say newspaper, you say
paper, news.
Okay, you got the idea that we have to reverse it. So I say this is 10, 4, but we're going to reverse it. 4, 10, and we're going to, teen means 10. We also have to switch the 10 to teen. So that's where 14 comes from. We can thank the Romans for switching, turning numbers around. Even when they write their 4, they're 4. I mean, they're 6, no, 4. It's IV, 1 before 5. They like to switch things around. I have no idea what went on in their brains.
Yeah. And the Romans didn't even have a 0, right? From my understanding.
They didn't need it.
Yeah. Oh.
What do you need it for?
I see.
Yeah,
Yeah.
No, they didn't have any. See, the year 0 has 2 meanings. It's a placeholder. Well, they didn't need a placeholder when you write a 5V11. That's what it is.
Yeah, exactly.
Yeah.
Yeah, they didn't need, for example, didn't need to write 10-0 because they had an X.
Well, the Greeks didn't have one either.
Oh.
They didn't need it either.
Wow.
It took the Europeans 800 years to accept the 0. And we expect our 5-year-olds to understand it.
Yeah.
Yeah.
Wow.
Yeah, it's a tough concept.
Mm-hmm.
So, anyhow, let's continue on here. 16, 17, 18, 9, the same kind of thing. Then we're left with just 2 odd numbers. Well, they're not mathematically odd, but 12, 10, 2, 10, 2, 12. That's where that comes from. Then we're left with my favorite one, 11. Where in the world did that come from? Well, these Romans, one day they thought, I think a good name for this number is, let's name it a one left. A 1 left, because 1 left over 10. So let's name it a 1 left. But we're going to switch it around. Instead of saying a 1 left, we're going to say a left one, which turned into 11. And that's the derivation of the word. So there is some sense there. How about that? So then this abacus is unique because it has a back side, which is a little bit more like the so-called traditional Chinese abacuses. These 2 wires are thousands. I use 2 wires and not 1. These are thousands, these are hundreds, these are tens, and these are ones. And I like to keep the 2 rows even. So let's say if I add 6 and another 6, if you want to hold it and make it a little easier.
Sure.
6 and 6. Now we can see the answer is 12 or 10, 2, because all the yellows make a 10. So it's 10 and 2. Well, we can't have more than 9 in a position. That's one of our rules. So we have to do a trade. I like the word trade and not exchange. So I'm going to take 10 off and put 10 on, because these are the 10. And you can see my answer is still 12. Isn't that cool?
I remember learning this in 2nd grade in China. I didn't do well on it, but I remember this.
Well, I did it with my 5-year-old's 4-digit numbers.
Wow.
And they only did about a dozen numbers, and they could do it on paper without the abacus.
Wow. See, another reason, millions of reasons, but another reason I wanted to bring you on is because by seeing your book and seeing you show me this, it vindicates what the teachers were trying to do in the 90s when I took the abacus test. See, I shout out Professor Carla Hoff. I've told her about this, but in the 90s, China was going through a lot of changes, and the education system definitely was, but also there was a lack of understanding of student-kid psychology in the teaching. So teachers would hit students, kids with ADHD would get beat up every day because, oh, you can't control yourself. But one of the things that teachers love to do is when it was kind of their fault they couldn't teach, they would blame the students. Oh, you guys are just stupid. We heard that word every day. You guys are so stupid. It's the Chinese way back then. Not saying it's that now, but in the 90s it was like that. And the abacus was notoriously so difficult for the whole class. During the final exam, she just recycled the problem that we did for the practice exam. So we all got that question right. So I never completely learned the abacus, but this really vindicates what the curriculum was trying to do theoretically.
Wow.
Yeah, a lot about China. China's changed a lot, man, but wow. Let's talk about your journey as a student. When did you know that you were going to become an educator?
Actually, I was very shy as a child. I didn't speak to another child my entire kindergarten year.
Wow.
I could never see myself in front of a class. And I was a hesitant speaker till I was in my mid-40s.
Wow.
And then I went to Toastmasters. And I went all the way through that program. And the highlight of my career, I also have I haven't talked about my background.
Mm-hmm.
I have a Montessori diploma from Mario Montessori's son,
Wow.
which is quite unusual. And I also have a degree in master's in curriculum instruction and a PhD in math education. Wow. And I did my research on the abacus in a first grade classroom. And the class, at the end of the year, that particular school had a test for the first graders. And there were two classes. One did with this program and one did the traditional program. And the difference in the score between the two, the kids doing this, as a class, they scored the 99th percentile. You can't get any higher than that.
Yeah.
There is no such thing as 100 in that.
Wow.
So then the school asked me to continue writing. I had no intention of writing. That was not my goal. My goal was to be a speaker. So I spent the next 3 or 4 years writing curriculum. And that was difficult because I only stayed a couple days ahead of the teacher.
Oh.
That was hard. But now I know there are thousands of children who benefited from this.
Yeah. Yeah. Besides the abacus, what is something else that was so fun about writing this book?
Besides the abacus? Well, the multiplication chart and the things you can do with that. Do you know that you can reduce fractions on the multiplication chart?
I did not know that. Wow. So the multiplication table, we were forced to learn it in China, right? Which benefits me till this day. I still know my multiplication tables in a way that's different than anyone speaking English. Because of the way the language works, we have fewer words to memorize. But I talked about that in another video. We don't have to talk about that now. So let's talk about multiplication tables and fractions. Wow.
Fractions. Oh, fractions. Yes. I don't remember how China did fractions. Did you do pies? Circles?
I think so. So the one thing I will say about fractions in the way that Chinese, and I can imagine how the Koreans and Japanese learn it, is we actually understand fractions better because the Chinese language tends to be self-defining. So like when I describe a fraction, I'm already describing what it is. Does that make sense?
Yes, that's what I understand. Whereas in English, we use the same words like third in a row, the third number or something. Whereas, and that's 1/3, there's no connection between 1/3 and the third day of January.
Yeah. In Chinese, for example,
there are different words.
If I were to describe 1/3, I would say 1/3, which means I have one thing I'm dividing into 3. I just described it. So like if I didn't know what 1/3 was, just by saying the word, I explained it, right? Like I remember when I came in 5th grade to this area, and fractions, I'm like, why would they say top number? I guess if you're describing it descriptively, yes, top number divided by bottom number, right? Yes, that is descriptively what a fraction is, but how does that help a kid understand what a fraction is?
Well, it's even worse than that, because we usually say a fraction is part of a whole. And my little phrase on that is, a mathematical fraction is more than a part of a fraction.
Yeah, exactly.
It's more than part of a whole.
Yeah.
Because a fraction can be any number.
Yeah.
Actually, I have a fraction chart here.
Mm-hmm.
But 1 divided by 3 is 1/3. And some people even think it's two numbers, as you were saying. It's not. It's one number. Just like 31 is one number. 1/3 is one number. It's 1 divided by 3. And this idea of proper and improper, that's nonsense. Who cares? And in algebra, with A over B, who cares if A is bigger than B? Makes zero difference. Makes no difference whatsoever. Incidentally, in this book, I show 12 ways of subtracting mixed fractions.
Wow.
There are 12 ways you can do it.
Whoa. Oh, guys, is this on Amazon? This book? Okay, guys, you guys have to check this out on Amazon. I think I'm going to put a link.
I don't think Amazon is selling, but if you put my name in or the book's name in, it comes up.
Okay, so I'll make sure you guys can search this up. So you guys, yeah, it just seems like, how do you develop a love for this stuff? Because as I started studying for grad school, I started realizing this stuff is fun, especially if you go back to the first principles and really learn it correctly from the start. Like, people be like, why would you learn it from the start? Because you build from it. Somewhere along the line, especially in STEM fields, you're going to realize, oh, I had a stumble block somewhere, and that's what led to other problems. Like, that's the beauty. You can't do that as much in social science but especially with math. If there was some concept in Algebra 2 you didn't completely understand, it might not affect you in pre-calc, but it'll definitely affect you in calculus or multivariable calculus. So just went on a little rant, but the key is, why would you have fun with the basics? Because from this, you're going to find everything from algebra, geometry, pre-calculus, calculus, beyond differential equations. It's all going to be easier because you learn the basics correctly.
And you'll have a better attitude. And you didn't ask either, how do we actually learn these facts? We get so hung up on the kids learning facts. Well, yeah, you do in China too.
Yeah, China's all about facts. There's no opinion.
Yes. And the answer is, we have games. I've written a book of games, over 300 games.
Wow.
All the way from learning basic 1 all the way up through fractions. I don't talk much about the games in there, but I do have a separate book. For example, one of the games is called Go to the Dump. It's actually a Go Fish type of game. Actually, my game was out before Go Fish. Neither name makes any sense today, but don't get hung up on the name. So in the way the game we play, what makes 10? So if you have a 4 in your hand, what do you need with 4 to make a 10? You need a 6. So that's the card you ask for. Those are your pairs that you're looking for. So of course 5 and 5 makes a pair, and 8 and 2 make a pair, 9 and 1. And children will play that game for hours. And at first they use the abacus to find it. And then pretty soon, one little girl in my class learned that 8 and 2 made 10. And she was so proud she didn't need the abacus for that one. She needed it for all the rest. So she knew what she was learning. And she knew she was learning. I hate that phrase that kids don't know they're learning when you're doing something with them. Kids want to learn. We should be that way all our lives. Yeah. We want to learn.
I would argue, again, I'm a Christian, I would argue there's something very spiritual in learning too. Like when you're learning, you feel like you're receiving something from above. I mean it. Like I realize that's one of the beauties and why I got back into let's embrace learning. There's something extremely spiritual to it.
Yes. Well, yes. We come into this world knowing very little. And we are designed to learn. It glorifies our Creator.
Yeah.
We need to learn and to understand. If you understand something, you don't have to spend nearly as much time memorizing it. In fact, one time talking about memorizing, and I said, if you memorize something in Swahili, would that do you any good? In other words, if you don't understand it, memorizing it does not, and it doesn't stick. If you understand something, you go back. I one time was giving blood, and a woman there, we were talking about how many pints or how many gallons, and we needed to know 8 times 8. One woman there could not remember 8 times 8, and she had no way of figuring it out. She was so flustered, she spent the next half hour talking to everybody about 8 times 8. That was just amazing.
Yeah, that's a perfect first principle example. It's like, even if you forget it, you want to have equipped in your arsenal a way to derive it again.
That's right. And there's all kinds of ways she could have done it, but no, she just could not get past that.
The hardcore way, of course, would just be to add up eight times. So, but Obviously, if you had an abacus, it would be really easy.
Yes, or you can think of 8 times 10 is 80 and then go back.
Oh, yes.
Like 60, yes.
Yeah, exactly.
Yeah, well, even on here, 9 times 3, you can see it's 30 minus 3.
Yeah. Yeah, in fact, that way is actually, you can simplify a lot of these problems by going backwards. I learned that like 9 years ago, but so you don't use it, you kind of just
Here's
forget.
one of my favorites, 7 times 7, and that's considered a hard fact. All the dark blues over here are 25, right? You see the yellows here? That's another 10. Whoa, sorry, I didn't do that right. 25, there's a 10, and here's another 10, and the last 4. So it's 25, 35, 45, 49. And a student is considered to know a fact if they can give it to you in 2 to 3 seconds. And it doesn't take 3 seconds to say 25, 35, 45, 49. And you have a mental picture of it. You can see it in your head. So see how simple that becomes.
Wow. How long did it take you to write this book?
Well, I wasn't just doing that, I was doing other things too. But we spent several years.
Mm-hmm.
And then the editing, as anyone who's ever written a book knows, the editing takes quite a while also, so it's been edited. And then finding the resources, the references, checking them out. And sometimes I give the page in the book too. So, yeah, it's took a while, but it was something I kind of wanted to do. So I've written the RightStart program, going from kindergarten through middle school.
Mm-hmm.
And students who do it are doing very well. We have one person working in rocket science now. Yes, and the best part, in fact, our motto is to help children understand, apply, and enjoy mathematics.
Enjoy's the key. Because once I realized I can enjoy math, Edward has seen some of my videos I made on math, and we just made another video on math. But yeah, once you realize you can enjoy, it makes wanting to learn the first principles or wanting to learn different methods even better, because you already enjoyed it. Now I'm enjoying it even more.
Yes, it's very important. And children going off to kindergarten love math. And yet 50% of people in this nation have math anxiety. And well, to me, it's morally wrong to make somebody dislike. I'd rather not teach them anything than teach them so that they hate it.
Yeah.
I mean, think about food. Supposing you made your child hate food. Would you be a good parent?
Yeah.
No. Math is one of God's gifts. And it's, as Galileo said, you have to, God created, math is one of the tools that God used to create the universe.
Yeah. Powerful. And if you learn it right, I'm not going to say it's easy, but math is not supposed to be too hard, okay? I will stand by that. Like, I will stand by that in my entire lifetime.
Yet, one of the most difficult things that you have to do in your life is learn how to walk. That's hard. You're going to have skin knees and worse. It's hard.
Yeah, falling on your head.
But we don't say, oh, that's just too hard. You can wait another year.
Yeah, exactly.
You don't have to do it. You can crawl all your life. We don't mind. But no, we encourage them. Yes, it's hard, but it's something you can do. Just because it's hard doesn't mean you can't do it. So the idea that, well, I think it's one of the Asian countries said, you can learn math with good instruction and hard work. We don't have to keep saying it's hard, but we need to respect that.
Yeah. Do you have any other books that you've written?
Well, the whole RightStart series.
Okay, I see.
And the one on card games.
Yeah, that's right. I saw the card game.
It's another little book we've written, actually for children, called Yellow is the Sun.
Yellow is the Sun.
6 is 5 and 1. Why is the sky so blue? Can you sing that one?
Oh, we're gonna get Emily to come. Emily's there. Oh, Emily's gonna come sing for us. Oh, she doesn't know it. Okay.
Well, she was stupid. Apparently, she's conveniently forgotten. Actually, I had to sing that last Thursday at a conference I was doing. But it's yellow is the sun, 6 is 5 and 1, and use your fingers. Why is the sky so blue? 7 is 5 and 2. Salty is the sea, 8 is 5 and 3. Hear the thunder roar, 9 is 5 and 4. My ducks will swim and dive. 5 is, my whole hand makes 5. And then it starts over again. Yellow is the sun, 6 is 5 and 1. Why is the sky so blue? 7 is 5 and 2. Hear the thunder roar, 8 is 5 and 3. Something about 9. 9 is hear the thunder roar. And then ducks will swim and dive.
Yeah, my whole hand makes 5.
10.
10, yeah. I see.
And you can download that on our website, which is, may I say that?
Yeah, please.
RightStart Math, and right is RIGHT, RightStartMath.com. And it's got a lot of information on there.
That's great. RightStartMath.com. Wow.
And a lot of parents like to use the card games books just over the summer to keep practicing.
Yeah.
In fact, Andy, my son, learned all his fractions just by playing the games in the fraction section.
I'm so excited to go to the fraction section because I'm telling you, in algebra class in middle school, the teacher had to make us repeat this because we were so scared of fractions. Fractions are your friends, she kept saying. Fractions are your friends. Why were we scared of fractions? Because again, fractions aren't taught too well in the standard school curriculum. So if I could make fractions fun, I'll go through this too.
Well, let me tell you my favorite fraction story. I was tutoring a boy with learning disabilities. He was in 3rd grade, and this was a few years ago. At that time, they did not teach fractions earlier. And not only that, two school districts didn't teach the same thing. There was no consistency. So, and he was moving out of the district. And on the last day of school, I said, Michael, let's spend our last day doing fractions, because maybe your next school will have done something with fractions. So I have a fraction chart with a 1 and 2 halves and 3/3 and so on. I had him put it together like a puzzle, and he enjoyed that. Then I asked him, how many fourths make a whole? Well, he counted 4. How many fifths make a whole? Incidentally, only half of 4th graders know that. How many eighths make a whole? And I asked him that. And then I asked him to compare fractions. Which is more, 3/4 or 4/5. It's pretty easy doing it with the linear, but it's much harder on the pies. And I kept asking him questions like this. And finally, at the end of 45 minutes, he said, now, Michael, don't think you know everything about fractions, because we have not done something like 1/4 plus 1/8. Michael did it in his head.
Wow.
A learning disabled child with only 45 minutes of instructions could add 2 numbers with unlike denominators.
Wow.
That's my favorite fraction story. I have another fraction story too. My grandkids.
Tell me, please.
John was in 3rd grade, and he didn't have a very good teacher. And his little sister was in 1st grade. And I asked John, which is more, 1/7 or 3/7? And John thought long and hard, and he said 1/7. Because the teacher had taught him the smaller the number, the bigger the fraction. Of course, he confused what was smaller and what was larger. So John needed some grammar time. Now, in this household, the kids can stay up past bedtime if they're doing math with Grandma Joan. In fact, John once kept me up to 2 a.m. So anyhow, we didn't stay up late that night. Anyhow, so I started working with John, and then his little sister, Anna, she wanted some grammar time. So she wanted to do the puzzle. So she started doing the puzzle, and she said, stop. And then she started arranging. She collected all the halves, put them in a pile, collected the thirds, put them in a pile, and the fourths, and then, each one all the way down to the 9ths and the 10ths. And then she said, all right, Grandma, I'm ready. So I started timing her. She said, stop. Then she puts them in order. She puts the halves first, the thirds, the fourths, the fifths. I'm ready, Grandma. Of course, she beat her brother. That was so important.
what's interesting, and I will show you guys this right here. Notice if you put the fractions, just arrange them, it's actually really pretty. I've never enjoyed the aesthetics of it.
Oh, yes. That makes it beautiful.
Yeah, if you just break the fractions down, it makes a really pretty graph. And actually, I think there's like a really long one here somewhere. But like, I'm a person that likes, look at this one. It's really cool to see things broken down. I mean, I think it was the Greeks, right? There was so much about the golden ratio and stuff. Like, there's something beautiful about if you just keep breaking things down. It creates a really cool symmetry.
Yes,
really cool.
And don't have them colored. They must all be the same color because their eyes will stay in the same color. We want to see the very first page here.
Yeah. Yeah, I'm a chess player, and I became a chess player much later in my life. But what attracted me to chess was when you see certain patterns, it kind of like shows some kind of hidden beauty. And I realized the same with math. There's a lot of hidden beauty that shouldn't be hidden if you were taught it just in a more fun way, in a more relaxed way. This is me going on another rant, but I think part of the reason, again, the year 2000 was the year that they started the No Child Left Behind stuff. I think that stuff put too many tests on little kids, man. Anyways, let's keep talking about this. That's what I'm talking about. Yes, this is the one I'm talking about. Look at the beauty right there. You just break it down. And look at that. It creates a really cool, I don't know how to describe it. Some of you might be able to see what I'm seeing.
It's a hyperbola.
It's a hyperbola. That's what it's creating. Exactly. Thank you for showing me what I was seeing. Yes, it's a hyperbola. It's different hyperbolas, basically.
We have one of these in wood, and you can even stack them and see the hyperbola. Wow. So it's really, really, really clever. Unfortunately, a lot of manufacturers make this chart, and they skip the 7th and the 9th, and they throw in the 12th. There goes your hyperbola. You can't skip numbers you don't like. Besides, we need 1/7 for pi. 3 and 1/7.
Oh.
And don't we have 7 days in a week? But actually, Common Core says you don't have to teach 7th or 9th.
I didn't know that.
Yeah, I'm serious.
Common Core says you have to teach 7th and 9th?
That's right.
Why? Because in their mind, 7 is 5 plus 2 and 9 is 4 plus 5. Is that why?
I don't know.
Okay. Ooh, I was defending Common Core for a while, but if they have some bias against a 7 and a 9, I am not happy.
Yes. So, and we do a lot with geometry too, which this book does not have in it.
Mm-hmm. But the part of the curriculum, there will be another book that's all about geometry.
Well, let me tell you about what we do with geometry.
Mm-hmm.
We use a drawing board, a T-square, and triangles. Drafting materials, but they come in nice, we have a nice small size. And I did this with my 5-year-olds. They made an equilateral triangle, and they divided into halves. They divided into thirds, fourths, sixths, eighths, ninths, 12ths is beautiful. And one girl, kindergartner, she divided that equilateral triangle into 256 equal pieces.
Wow.
And she could explain it to you how she did it.
And it's training them.
And today she got her medical degree from MIT.
Wow.
Harvard. And she's an oncologist, radiologist in Mayo Clinic in Rochester, Minnesota.
Wow, that's amazing.
Yes. I was able to track her because she has an unusual name.
I see.
Yes.
What I love about just that way of teaching geometry is like you're preparing them for hands-on work. Whether they want to be a carpenter, they want to be an electrician, they want to be an oncologist. You're teaching them to work with these materials and you're applying. It's not just, I'm on a teacher on a board giving you problems for a test. You're literally applying.
And the last thing that the students, the middle school students, they're asked to make something original. And we've got them online. You should see some of them. Some of them are just absolutely
Is it on
amazing.
the same website that you gave?
Yeah,
Okay.
yeah.
Mm-hmm.
Yes.
That's amazing.
Yes.
So, last question for you is, what's next for you?
Well, I'm reluctant to announce that because people will say, when you're going to be done.
But there is something big planned. Okay.
Yes,
All right.
yes, there is.
All right. And I would say another what's next is let's get you back soon. Next time you're in the area, let's find more topics, whether in math, other types of education, anything else you want to talk about, we could talk about.
Okay.
So leave your questions. Leave your questions for Joan or Dr. Cotter, and just give us your thoughts. Give us your frustrations about math, science. If you're a math person, give us your frustrations about the humanities, because shout out all the students in the library I talked to. Most of them are actually very STEM capable. They are not as capable in the humanities. So I'm like meeting the opposite version of myself.
Actually, I viewed the aeronautical space and science in Smithsonian yesterday, and I was disappointed. There's no science there. There's no science there, and definitely no math there.
Uh-oh.
And I don't think the Wright brothers worked without that.
Yeah. Yeah.
And we had a tour guide, and I asked him something on science, and he didn't know.
Yeah.
That was disappointing.
Yeah. So let's make math fun again. Let's start math right again. And no matter what age, okay, you can start math right. I humbled myself last year when I started relearning math. I mean, I relearned talking about from the basics. I relearned the commutative and the distributive property. And then from there, I realized that's what factoring is. All that FOIL nonsense they made us memorize, it's basically the distributive and the commutative property. But nobody explained that to me.
Well, I've always thought it was really kind of neat that 3 times 4 is the same thing as 4 times 3. Actually, I have a recipe that takes 1/12 of a cup. Now, how do you do 1/12 of a cup? I do 1/3 of a fourth, or 1/4 of a third. There's your commutative property.
See how she's making it fun? Like, this is something, as a parent, as a teacher, you can play with your kid or your student. How do you make a 12th? And then just go through these things. 1/3 of a fourth, or 1/4 of a third.
Yes, because I have measured cups that are a fourth, and I have 1/3 of a third, whatever I have handy. I just remember 1/4 of a third is the same thing as 1/3 of a fourth.
Yeah, exactly. I'm telling you, if you just remember the commutative and distributive property, and you really, really kind of play around with it, you can actually explain a lot of things in algebra.
But you also better remember it doesn't always work. Doesn't work for subtraction.
That's right. Because
sometimes kids want to subtract that way, it doesn't work.
Yeah, we got to remember PEMDAS also. By the way, PEMDAS is not the best memorization technique. I just said it because that's what schools say. But yeah, you got to remember your order of operations, for lack of a better word. So, we could talk for hours, and this is a good stopping point. Leave your comments, and we'll definitely have you back. So thank you so much. This was awesome.
Well, thank you, Jerry.
Yeah.
Thank you.